How's it going, everyone? Welcome again to another video on the React performance. As a way to now finally wrap this section, which is a course taught by Steve Kinney, head frontend engineer at Temporal, this open source tool that provide now a durable execution platform. So you can think of this like a Kubernetes, where the whole point of that is to provide that to companies. So for example, like Versos, where you can now is, or in their case, they allow now to the clients some of these particularly platforms, some of this specific resource that they can go with that with their machines. So the whole point of this, or at least in today's videos, is to now take a look at the React Dev. Okay, and after a month and a half to actually look at this and understand how all of these different sections in the Learn module about describing the UI, adding interactivity, managing a state, and therefore is skip hatches, how all of these different things fits together and how you can combine them as a way to build user interface. Not only that, but also how you can scale that user interface as a way to build now applications. So the natural step of, so after we look at React, and then when you combine with TypeScript as a way to make not only your code base much more easy to collaborate when it comes to work with large code bases, which you are now putting all of these guardrails, and make the errors happen at development time and not at run times, which is something helpful, especially if you for some reason are tired or you're kind of lazy, and then you help you to prevent some of these common human errors, as well as that provide you this autocomplete feature, which improve the developer experience vastly. So the next step of this is to then look at how you can design system design in frontend. And I see all of this is a progression. First, you started with looking at how you can create this specific applications. So for example, with React, with JavaScript, understanding is the browser and the server, and then JavaScript and how JavaScript fits in here. The new and latest features of JavaScript that allow us now to build and understand is how you can write UI elements, as well as how all of these different UI things, or the concepts that now React, for example, provide you as a way to now build this UI. So concept not only from the language, such as closures, and what are the patterns that closures allow for us to, for example, memorize or once, as well as enables this the iterator pattern, and also the promise pattern as well, which is using something behind the scenes, as well as the generators, in how all of them actually fits as a way to now write your applications in React, and then how you can now is, at the end of the day, by understanding all of that, how you can now build solutions to a particular industry, whether it's finance, e-commerce, that kind of thing. But the point of this is to see how you can now provide that to those companies. That's where it comes this system, so the design system, especially on the front. So That was quite interesting because there is also a front-end master, by the way. A front-end master is this system design, right? System design, like Yegniv, I think it is. His name exactly. Yegniv, right? Or Efnegi, I don't know how you pronounce that name. Ooh, chill, bro.
Hi, my name is Evgeny Ray,
Evgeny, exactly. Evgeny Ray.
and I work as a front-end engineer. I created this course because UI engineers need to understand the fundamentals of system design to build complex storage
Completely. This is the natural step. So UI developers need to understand as the fundamental of system design.
scale apps. In this course, I will cover the fundamentals of how the browser works, DOM API, the Observer API, and how fundamentals of system design to build complex large-scale apps. In this course, I will cover the fundamentals of how the browser works, DOM API,
You're using it as a web server, interesting.
the Observer API, and how to build virtual lists, application state pattern, networking patterns, performance optimization, and in the end, we'll do a mock system design interview building a social newsfeed. With this knowledge, you'll be able to understand how to build scalable web applications.
Because at the end of the day, that's the whole goal of it. It's like, okay, so with all the things that you have learned, how you can now build this scalable application, the front end scalable application, or at least in theory, or at least in theory. So yeah, that's actually quite interesting. It's actually quite interesting. Okay. Application state and network connectivity, and web application performance. And then he introduced the system design interview, social media news feed, as a way to how you're now going to describe how you're going to do this. But again, all of this is to just get a job. but but that's great. That's great. In today's video, we're gonna focus our attention is on React here solely, and then which is on the escape hatches. I'm not going to walk through all of these different topics here. And in fact, I just want to briefly mention each one of them. So when we are now here as a way to understand what is the goal of this course and in today's video, so if all of this is to see how you can now write performance React components, therefore React performance React apps. And to do that, so in order to optimize something, you need to know how that things work behind the scenes. That's where we go dive deep into the not only on JavaScript but also in the data structure and algorithm. Something that I'm actually doing here with the Neatcode, all right, as a way of how we can actually truly understand all of these different tools, data structure, and algorithm to solve real life common problems. So these tools like arrays, so data structures like array, stacks, queues, uh, linked lists, double linked lists, binary search, tree, tries, heaps. So all of these different tools that allow us to do this, as well as the algorithm. So for example, sorting, uh, in search, right? So this go beyond the scope of this today's video, but the whole point of this is to see how now all of the things starting to make sense together. Uh, so this is a one way of how you can learn something from top to bottom, all right? as a way to now deep dive into all of this intrinsic nature, especially if you don't have access to all of this information, if you don't have access to a formal education, okay, which is, unless you live in any of these rich countries, you will have now this formal education that most of the time will give you is a lot of is anthropology, archaeology, the fundamentals, and then you can now, for yourself, you need to is still learn about what is the thing from all the things that you have learned. What are the things that are now in demand in that industry or in the market? So in any case, so I think this is quite interesting. Okay, as a way, in my perspective, or from those who don't hold any background in computer science, or for example, those who don't have any formal educations, starting from top to bottom might be the best, might be an alternative, but it's also time consuming. Okay, so you better be actually is define a goal, do a time schedule, uh, and also put schedule or do this time blocking as a way to now, over time, the compound interest is something that is wonderful. Well, I'm a testimonial of that. I'm not a testimony, I'm a testament of that. Well, in any case, here we are. So, because we are looking at the React performance, we need to know what React is. After all, I'm going to briefly describe all of this, and then dive deep into what we really care about, which is this last four models: life cycle of React effects, separating event from effects, even though that this is in a beta state, removing effects dependency, and reusing logic with custom hooks. So, after all, React is this framework that is a JavaScript framework that allows to describe its UI. So, for that we use JavaScript function. We look at how can we import and export components. How can we now declare our UI using the JSX syntax, and how can we pass now down data to these components. How can we conditionally render components, lists of components, or rendering a list of elements here, and how important is from the React for you to understand that as you're going to write your UI, it is important to be now as pure, which means this is a mathematical concept where they say given an input you will always get the same output. Why is this? Because I don't want to dive deep too much. Just to mention what is the benefit is it allows you to your component run in any JavaScript environment. So for example, the server. It also allows you to now can catch some computation by using some of the React building tools. And also it is safely to stop the execution of one of those components and then resume that again. So also we look at the way of now how React sees your components, and using is this computer science data structure called trees. And then you have now the render tree, which is now how all of your component is gonna get rendered as you add in to your application. And then the tree dependency, which is now this logic, reusable logic that you can use in your applications. And how now, by understanding is the architecture, the React render tree, how you can now understand is how the data goes through that one-way data flow, as well as if you have any performance bottleneck there. And when you take a look at the tree of dependency, you can identify which one of this logic you want to actually use that or not, as a way to reduce the bundle size of your applications. Why this is important? Because especially if you're depend of your product, if you are going to serve this UI elements or this application over the internet, the more lightweight it'll be, the better off, especially if you're targeting clients in low coverage or poor coverage areas, or poor call coverage. That's something that you have to keep in mind, this performance budget. But in any case, so the other is now how you can now add interactivity, because at the end of the day, if you just write this component, it's pretty much like writing is HTML with a lot of boilerplate code. So how you can do that? Add this interactivity by defining as an event handler and a handler function, okay, and then connect that to the GSX. Because most of the time we want our applications to show some data, and then based on user interactions or user inputs or any input, whether it is computer or human inputs, it changes, it updates the data. So that's where we have now states. So state is a way of how you can remember things in your components. So all of these things is the way of how now you starting to sue this concept. And from that, let me take a break here. Yeah, and from that, all right, by understanding that the state is the way of how you can now is show data, and based on a particular input, you're going to update that state. So here, anytime you want to update an state, which happens is inside of your event handler, usually, uh, it trigger React behind the scenes a rendering mechanism, which is the way of how now React actually update your screen with this relevant data, with this new state. So this mechanism is made of the trigger, render, and commit. The trigger is, as the name suggests, when this state happens, when this state update happens. The render is, okay, now what I'm gonna do, if this happens at the root element, I'm going to now is create all of these elements using the React create elements for that. However, if this happen at a also render, then what I'm gonna do is to call the component that triggered that state updates, compute all of that components, the probs, the states, or any other values, reactive values, as well as the event handlers, okay? And then the output, which is a GSX element, if this contains more React components, I will continuously call it in a recursive way until there is no more components. So this process is when this thing called the VDOM is created. And this VDOM is just the representation of the ideal UI that is kept in memory and synced with the real DOM. And this process is known as the reconciliation. Why is this? Because this is the way how now you as a developer interact with the React API, and you tell your UI, you tell React, hey, this is the UI I want you to be. So match that state with the DOM. So instead of us having to manipulate that element, so for example, having to update the attributes or the DOM elements or manipulate the DOM elements, this is all of this is taken care for us with React. Of course, it comes with a complexity, with a trade-off, as any tool, and that is that we need to know how is this things is working behind the scenes, and that is when you're now or when React is doing that work, okay? The React team develops this thing called the React oh my god, the reconciliation engine which inside of this is now contains the VDOM and adds some information. This is known as the React fiber. These React fibers is now lay out the foundations to unlock new features in React. So for example, new features like concurrent rendering. So this is when you can use transition from that, or rendering prioritization, like use defer, as well as the ability to stop, start, and resume a rendering. So again, the whole point of this is because you are going to solve, they are going just to solve is Facebook problems. And most of us don't have Facebook problems. Unless you're working for, and again, if you have that kind of problem, please send me a check. I will gladly to help you. I will gladly to assist you. Yes, yes. So, but in any case, this is now the process of the React, okay? And we were just talking about is the rendering, and when now React knows what it needs to update or to commit to the DOM. So if this was caused by the initial render or by the root elements, now based on the previous stage, it now contains all the information that is going to append to the DOM. If it was caused by a re-render, it's just only going to apply the bare minimum necessary change as long as they're different between renders. So when that happens, okay, the epilogue is that the browser detects those DOM updates and then, alright, paint your screen with this update state. This is a mechanical process that happens over and over and over and over, and because of that, we also need to look at how can we update our state in our React component. Okay, exactly. How can we update our state in our React component? So, what ended up happening here is that we need to think of our states as a snapshot when we are updating them. So our states, as we are updating, they are synchronous inside of our event handlers. And the other is that our state update value will be reflected is in the next render. How also can we now queue series of state updates, okay, as part of the way of working, for example, in async operations as a way to inside of that event handler, because after all it is synchronous. How can we work it with the previous state and so on and so forth, using is now an arrow function. And how can also with update is our objects and array in our state. The TLDR is always returning as a new object or a new state from that. If you want to make your state update logic consist, you can use IMER for that. And then how we can now scale our user interface. In other words, how we can manage our state as a way to say, well, now that we got this particular state, how can we now represent, or how can we think or UI change as state change? And now React actually provides us a particular guideline on how to think about that, because this is now more declarative instead of imperative, the trade-off about each one of them. And if you're going to develop your UI, it is first important to identify is what is the different visual state of your UI, and then determine what triggers those state updates. Okay, represent those states in represent those state updates in as a use state in memory. Avoid any non-essential states, and then update your state or and then update your event handlers, or change, or uh, write your event handlers where you're going to update your state. So all of this different process here is just as a way of how you're going to translate is this design, whether it's from whether it's wireframes or mocks, or data models, for example, well structured JSONs. Yeah, for example, well structured JSONs as a way to understand is this. Now, with this, then I also look at how now can we organize our states using as well some of the principles that they provide. So, for example, it's like avoiding non-essential group related state together, avoid contradictory states, redundant states, uh, duplicate states, as well as nested objects in your state, and then how you can now share that state across different components. How it's important to think about is the uncontrolled components and control components. Even though that this is not a technical term, it's just a way of how you going when it comes to design or you write your React components, how to think of them. Okay, hey, this component is uncontrolled because uh, the main information now is driven by its state, and the main information is something that we're going to explain that later. But is what are the state? What is the elements? What is the data that this component needs to keep track, for example, or wants to represent? So the other is now how you can make, for example, when you're going to write your components, uh, how you call a component that is controlled when the main information is getting by its props. Even though there is no need to actually remember the things, but it's just useful as a way to now keep up the pace with React and understand some of these concepts. And then, how can we now share that state? Okay. Also, React provide us is a particular way of how you can do this by saying, all right, now for us, when it comes to describing or writing small applications, uh, how helpful is to think in terms of React, which is, hey, do we get the data models or the wireframe? Either way, we're going to now create this component hierarchy of the UI. If you have now a well data structure that actually naturally falls into that, because the shapes are the same, the architecture of the data model and the UI components are the same, so you can start from that. Then you define is now a static version of that, which is describing is only the data that those components will need. So when you do in this phase, it requires a lot of typing, but less thinking doing this, this that or this static version of your React components. Uh, we're now in the next phase, which is now find the minimal but complete representation of our UI. Is to say, well, this part requires a lot of thinking and less typing. So this is when you recognize or wants to identify is this state as a way to say, if this data doesn't change too often, that's not a state. If this data comes from its props, that's not a state. If I can compute this data based on its props or in its state, that's definitely not a state. What left might be an state, might be a representation of what you want to keep track here. So once you identify this minimal UI states, okay, which is an iterative process, Then you're going to choose which components actually owns that state, and that is that components will become the source of truth for all other components that make use of them. And once you do that, then you need to add this inverse logic, inverse flow. Yeah, add this inverse flow, especially if you're going to, if some of these child components actually make use of that state, and that is by passing is the event handler, or the setter function specifically. Passing is the setter function as well as the state. So in these child components can actually is now update that state as a way to now follow the one-way data flow. And then I also look at how can we now is preserve the state, reset the state, how can we make our state update logic maintainable by using reducer. When it comes to share data to different components, how helpful it is to use context as a way to prevent now these things called props drilling. And there's some caveat of using context, because anytime you React will re-render all the children components that make use of that context, starting from the providers, when that value change. So as a way to prevent that in your provider context, you can just wrap that value into its own reducer, for example, as a way to deal with the complexity, or some optimization techniques like use memo or use callback, which is say, hey, let's going to catch this between re-render. Let's going to catch this computation between re-render, or this function reference between re-render. So there are some small use cases with context. So for example, here when you want to store is a small piece of data, like the authorizations or themings or user login, and also for example the navigation is actually using context as a way to keep track where is the current URL that the users go through or is navigating or is currently at. And then when it comes now to actually communicate this UI to external systems as a way to sync or to control external elements, how we can use this now is use ref as a way to now have access to, most of the time, is the element ID or the timeout ID or the DOM elements, as well as the any JavaScript object that is not necessary or that is not needed at GSX calculations. So use ref is actually the way of how you can remember things without trigger a re-rendering. Okay, it actually have a property called current. That's right. And right below that we have is now the use effects. And with use effects, so use ref and use effects, these are topics that most of the applications in your data should not rely on. But again, after all, because we're building JavaScript applications that needs to talk to other computers, this is it. So in any case, yes, so effect here is a way of how you can now synchronize with external systems. So, because after all, the logic in our components are split by the rendering logic, which must be pure, and the event handle logic, which is when you can trigger now these side effects. So use effects is a hook that trigger caused by rendering itself, which is when this component render itself, you will gonna call this side effect code. And this happen is at the end of the commit phase. If you remember the, yes, you remember that rendering mechanism. So I think this is quite interesting. because now that give us is this ability not only to describe that, but also to see when this particular thing will, or this particular site code will run, and how you most of the time you don't need an effect, especially if you're going to update an state from another state. You don't need an state. You might not need an effect. That's actually a section. And how can we now is describe our use effect. There's a way to use effect. You pass now a set of function that by default it will run after every commit, because most of the time we don't want to do that. We pass is a list of dependencies, and this list of dependencies, especially in development, uh, you going because React now with the strict mode is the way of how they can make sure that your application works as expected. It will rerun your effects and recall or re-render your component as a way to prevent some common gotchas in your components. All right. So it is important to understand that how you can fit your effects as a way to how you can fit your effects to work with the process of setup, cleanup, and setup function in development. So this is what why you see your trigger function run twice in development. So I also look at what will be when you write your effects, what will be the typical pattern that they will fall in. Or you're connecting to an external system, whether it's a map box, or a leaf, map leaf, that kind of thing, okay? Or you are connecting to animations, uh, for example, you are subscribing to an event, you are now doing that affection, and here in this particular part is quite finicky, because at the end of the day, when you are running this side effect code, what happens is that since there is no way to undo this network request, the way of how you can now update your state space as the data you get from the server, uh, once you get the data from the server, is that by putting is the ignore flag or using some abort concept or abort API. But usually it's the ignore flag. So this is just a way to say when you mount these components, which is something that we're going to talk about that later, about the life cycle of this component. But when you are mounting that component, okay, how helpful is to ignore that when a dependency change. So because of this, which is a something that you also need to handle in data fetching, is duplicated requests, because your effect doesn't run on the server. So the server is actually pre-render that HTML, send that to the client, and then the client show the initial loading page, and then wait for that content to be low, make the request for the GSX, wait that content to be low, only figuring out that now it needs to actually do a network request. This is one issue. The other is this network waterfall. So if you have several components that actually is calling different resources in your server, let's say you have your application, you have your bank app, and in your bank app you have now the profile data and the balance account, the transaction history. So all of these components actually are fetching data from those resources. So now you have is this network waterfall, which of course slow down your applications, and also um, mhm, mhm. And also, all right, uh, now how you can catch that data, because when the components mount and remount, you need to also again call that data, and how you can deal with these race conditions, especially when you're typing is all of these things over and over and over. That's why we use, for example, the ignore flag as a way to, well, do not update our state uh, for any reason, or as the dependency array changes. So that's one of the things that's how the thing that you need to handle in your effect when data fetching. So that is a lot of frameworks out there that actually handle that for us, which is great. For example, Next.js, uh, Astro, Remix as well, or you can use this client-side catching libraries like the uh, yeah, catching libraries like the use React Query or React Routers 6.4, or the use SWC. But in any case, as what you actually are doing behind the scenes, and the things that you can use that. So also another pattern when you write your effect is for analytics. So you can just write your analytics inside of that as a way to know, hey, which one of how many times this page is visited, for example. So once we understand now how this effect will fit into most cases, and also when you might not need an effect, something that already something that we already know. So for example, when updating an state based on an state or a props, you don't need an effect. Catching expressions, catching expensive calculation, you don't need an effect. Resetting the state of a component, or resetting all state when a prop changes, you might not need an effect. In fact, you can go with the key value in that component. Adjusting some state based on props or change, you might want is to recompute that. Uh, the other is sharing logic between event handlers. You don't need an effect for that. Data fetching or sending an HTTP post, you don't need an effect. You do that inside of your event handlers. Chains of computations, you don't need an effect. In fact, something that we're going to talk about that later, how important is to think now your effect as the synchronization process that need to start or stop. That's all. uh, and how to think in terms of that is something that is uh, can give you now a notion when you need to write an effect or not. Initializing the application, you might not need an effect, especially you can just define this outside of the render component, and then define the initial state of that. So passing data to parent, you don't need an effect, or subscribing to an external store. Here they provide you now a specific uh, hook as a way to know keep track of that. So for example, like you want to keep sync with mouse move, or that things that happen outside of the React. So for example, like mouse move or connecting to a server. And when it comes now to understand the React lifecycle as a way to, now that you know what effects are, yeah, as a way to know what effects are, how you can write your effects, how you can how effect fits in the rendering mechanism, and also uh, when you need to write an effect, uh, when you don't need to write an effect. Okay, so what is the most typically pattern that will fit when you write an effect? when you might not need an effect, okay, or when you don't need an effect, uh, or might not need an effect, and then now how is this effect actually work? What is the mechanism of the React effects? And here is when we have now the life cycle of an effect. Is quite is different in terms of the component, because the component is component mounts, updates, and then upmount as the entire life cycle of the components. And in the effect, it is important to think that your effects can do only two things: start synchronizing to something, and then later on stop synchronizing. And this life cycle can happen multiple times if your effects depends on a props or an state that change over time. There's a way to pass now an array of dependency. And now how the linter or the React provides a linter rule that you specify this dependency correctly. So this keeps your effects synchronized to the latest props and state. So because we look at what is the life cycle, or how to think about the effect life cycles, exactly how to think about each individual effects in isolation, that uh, after all, your effects, it's going to run this specific code after the commit phase. So you have now is this particular life cycle on your effect. So you have, because I look at the anatomy of your effect, which is the setup and the cleanup function, followed by the array of dependency, all right? Mm-hmm. Mm-hmm. Then, because when we're passing now this array of dependency, when this dependency changes, so React will synchronize that effect. Or in other words, React will now pass through this effect mechanism or effect life cycles, which is when the component is mounted, by default it will run that side code effect. If you provide now an array of dependencies, so when the component mounts, it will of course run the setup code, okay? Then when any of these dependency change as a cause of the difference between the previous state and the new states using the object.is, okay, which actually check for the object.is here, the object.is, oh no, what? It's people that actually are having that. Runar. Mm-hmm. Mm-hmm. But I want to take a look now English here. All right. So static methods determine whether two values are the same values, okay? And when they say the same value, here is the values are the same if one of the following holds. Both are undefined, both are null, both are true, or both are false. Both strings have the same length with the same character in the same order, okay? Both have the same object, meaning both values reference the same objects in memory, okay? If both objects have the same reference in memory, is the same, both big ints with same numeric values, both symbols that reference the same symbol value, both numbers and both are 0, plus 0, minus 0, not a number, or both non-zero, not a number, have the same value. This is not, of course, equal to the double operator, which is actually do some type coercion, or the triple operator, where the only difference is that the treatment of the signs zeros and not an okay, and NAND values. All right, and NAND values. That's right. Okay, so that's interesting. That's very interesting. So, um, because now the way of how it synchronizes this is by using is the object.is. Okay. Instead, always focus on a single start. Exactly. They don't describe that too much. How this resynchronization happens, in thinking from the effect perspective, and especially when you're going to write your effects, how important is to think in them as an individual synchronization process. Okay, that start and stop. Okay, so you need to be able to describe how to start synchronization, how to start how to start how to start to synchronize, and how to stop it. React figured out the rest. So and also here, when now this component is going to be re-rendered or is going to be called, what is the life cycle of this, and how they mention it. Each effect represents a separate synchronization process. So you can define here is your analytic as a user effect, or in the end as a different effect, your data fetching, and as a different effect, your synchronization, you're subscribing to an event. But each one of these effects represents a synchronization process. And now, how the effects react to reactive value. This is now to understand that after all, React or effects needs reactive values in your array of dependency. Why is that? As a way to now is trigger that side code. So when that's changed, React will know when this side effect code needs to run, and you need to also use inside of your React. This is when the linter is helping you. And when you talk about reactive value, what it is, well, is any variable or any value that you define inside of your rendering logic. So for example, prop states or any value you define inside of that. So they become reactive. They're going to change at some point over time. And even though, for example, because they actually call that React, call these components, now it makes a lot of sense to define or to use some of this reactive reference. And remember that this reactive reference, if you define that, it will compute that. It will, anytime that that component needs, anytime that that component cause a render or detect a render, now it will compute that component. So we also look at how we can now is understand the specific process of the component's life cycle. For example, what happens when the component mounts, when this use effects, when the component mounts, and what happens when the use effect mounts, when this use effect is running. Uh, so, for example, when it one of the dependency change, what happened? So it's first gonna run the cleanup function and with the all state, and then the setup function. uh, and also, okay, how you can now is pass, or yeah, how can you is resynchronize, what to do when you don't want to resynchronize, because this process of calling this or calling this effect when the dependency changes, they call this is synchronization. What happened when you don't want to resynchronize? Okay, you define is your variables outside of the rendering logic. Mm-hmm. So effects are reactive blocks of codes. And when they say reactive, it means that it's a code that needs a reactive value, a variable that actually change over time. That those are props, states, or any variable that you define inside of your rendering logic. So that makes sense. So effects are reactive block of codes, and you can choose your dependency because they need to be is reactive. Okay, so even though the linter enforces this, okay, your dependency must include every reactive value you read in the effect. The linter enforces this, and sometimes this may lead to problems like infinite loops and to your effect resynchronizing too often. Exactly. So, yeah, the linter enforces this. Exactly, the linter enforces you that your effect, because this is your effects are reactive code block, reactive block of codes. Exactly, that makes completely a lot of sense. Okay, because your effects are a reactive code of block or block of codes. You can choose your dependency because the linter informs you that you must pass is a reactive value and read that inside of your logic, and that makes sense. That makes a ton of sense. So sometimes this might lead to problems like infinite loops and your effects resynchronizing too often. So because of this policy that linters enforce as a way to now pass to the effect, which is a reactive code, which is a reactive block of codes, you might end up sometimes with an infinite loop. So to solve these particular problems, here's where you can try. Here's how you can fix it. You check the effects that represent exactly. Check that your effect represents a separate in or yeah. Check that your effect represents an independent synchronization process. Okay. So if your effect doesn't synchronize anything, it might be unnecessary. Exactly. If your effect is not synchronizing to anything, you might not need an effect. If synchronizing, or if it's synchronized several independent things, you might need to split it up. The other is you want to read the latest value of a prompt without reacting. Uh, mhm, Without reacting to it and resynchronize the effect. Resynchronizing is running this effect again, but you want it to react to the latest value of a props or a state without reacting. This is when they talk about is that you can split your effects into a reactive part, which is the that you will keep in your effects, and the non-reactive part. This is now when you want to okay. Mm-hmm. This is something that is maybe is inside of your application logic. So, for example, a notification. So, if you want to read the latest value of a props or state without reacting, aka without triggering a re-rendering, mm-hmm, and resynchronize that value to the effect, you will have now is the effect part, okay, the reactive part, and the non-reactive part using is effects event, and avoid relying on objects and functions as dependency, because on every rendering they are different, because they are creating this new space in memory, or new reference in memory, and this will cause your effects to resynchronize every time. You definitely don't want to do that. Read more about removing unnecessary dependencies from effects. Okay, that was quite interesting, and I see why they might use this, for example. And also remember that is a so in other words, components can mount, update, and unmount. Effect has a separate life cycle from the surrounding components. In each effect describe a separate synchronization process that can start or stop. And when you write your effects and read when you write and read effect, think of them from the effect perspective as an individual effects, okay, rather than from the component perspective, okay. This is exactly when you're going to write and read your effect. Think of them as from each effect separately, from the effects perspective, which is a synchronization process. How you start and how to stop synchronization, different from the component perspective of the component perspective, which is how it mounts, updates, and unmounts. And values declared inside the component's body, exactly, and values declared inside the component's body are reactive. Reactive value should resynchronize the effect because they can change over time. And the linter verify that you are passing its reactive values to the effects and are specified as dependencies. And all error flags by the linters are legitimate. So there's always a way to fix your code to not break this rule. And I think this is one of the fundamentals of understand how to use this specific hook, which is most of the time what you're gonna do, and how you can not only write this, or how you can use this tool to cover most of the time, but also what is the end goal of this tool is to synchronize with external system, and that makes a lot of sense. Mm-hmm. And then separating events from effects like this. All right, that's a way to understand this a little bit more. Choosing between event handlers and effects. Okay. Mm-hmm. Mm-hmm. Okay. All right. Mm-mm-mm-mm. Okay. 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 All right. Okay. Okay. So now let's take a look at the separating event from effects. So event handlers only rerun when you perform the same interaction again. Unlike event handlers, effects resynchronize if some value they read, like a prop or a state variable. Yeah, this is separating events from effects. Event handlers only reruns when you perform. Event handlers only rerun when you perform the same interaction. That's true. Unlike event handlers, effects resynchronize if some value they read, like a prop or states, is different from what it was during the last rendering. So this effect will resynchronize if some value they read from the list of dependency, like a props or states, change at render time. Okay. whereas now the event handlers only happens when or when you perform the same interaction. So sometimes you also want a mix of both behaviors. Okay, sometimes you want a both of mixed behavior, so that an event that happens when the user interaction happens over and over and over, I want you to now run this side code effect. But exactly in response, an effect that reruns in response to some value, but not others. This page will teach you how to do that. So, how to choose between an event handler and an effect, why effects are reactive and event handlers are not, what to do when you want a part of your effects code to not be reactive, and what effects are and how to extract them from your effects. Okay, and what effects are and how to extract them from your effects. How to read the latest props and states from effects using effect. Wait, what? Why effects Why effects are reactive and event handlers are not? What to do when you want to what to do when you want a part of your effect code not to be reactive? What effects are and how to extract them from your effects? What effects events are and how to extract them from your effects, and how to read the latest props and state from effect using effects event. Choosing a state between event handlers and effect. First, let's recap the difference between event handlers and effect. Okay, so after all, an event handler is happened when you interact, when you perform the same action. That's when the code does run. Okay, the code inside of the event handlers is run when that is triggered, when you trigger that same interaction. And an event handlers in an effect is run when some of the dependency that is read, whether it's a props or a states or any reactive value, changed during rendering. Okay, so events handlers run in response to specific interactions over and over and over and over again. That's right. So event handlers run in response to specific interactions. That's right. This will happen as a response to a specific interaction. Okay, and your effect reruns whenever synchronization is needed. So whenever this resynchronization is needed, in this case from its props, it will run this. So far so good. So use effect will run whenever whenever a synchronization is needed, and the event handlers is whenever when the same specific interaction is performed. Okay, or run in response to a specific interaction. Okay, the event handlers run here in response to specific interactions, and the use effects whenever a synchronization is needed. Reactive value and reactive logic. Intuitively, you could say that event handlers are always triggered manually. For example, by clicking a button, effects on the other hand are automatic. They run and rerun as often as it is needed to stay synchronized. There is a more precise way to think about this. Props, states, and variables declared inside of your component body are reactive. Exactly. So logic inside of the event handling is not reactive, but logic inside of your event effect is reactive. If your effect reads a reactive value, you have to specify it as dependency. Then, if a re-render occurs, that value change React will rerun your effects logic at the end of the commit phase with the new value. And let's revisit the previous example to illustrate this difference. Logic inside event handlers is not reactive. Okay, remember that after all, the subtle difference between an event handler and an effect is that an event handler happens an event handlers happens uh, every time, or an event handlers happens when you run the same interaction, or as a response. The effects handler run as a response to a specific uh, interaction. Okay, that's what is the event. Okay, so that's what is the effects, the event handlers. So the event handlers runs uh, as a run in response and to run in response to a specific interactions, where now the effects runs whenever a synchronization process is needed. So the code inside of your effects are reactive because React needs to read the reactive values inside of your logic. The linters enforce you to do that as a way to now run this code at the commit phase when this dependency change. Okay, where now the logic inside of your event handlers is not reactive, and from the effect perspective and from the state perspective is synchronous. Mm-hmm. Mm-hmm. Okay. Okay. Logic inside effects is reactive. Exactly. Extracting non-reactive logic out of the effects. So for example, like this. So even though this will actually trigger whenever is a dependency change. So play with the example here, and you can see that whenever the room change, it will also is show that connected. So not only that, which is great, but whenever is the props change, for example here in the theme, it will also is, which is only when we want to actually change that. Okay, and exactly like show notification. And notification must be okay, Toastify. They're using as a Toastify, okay. So it not only going to change with the theme change, which is when we want to actually see that, but also it will run when you change to that, which is something that you don't want that. So when the room ID change, you are now resynchronizing. Again, this is now under construction, and they say, well, I want you to now is run this effect event, this non-reactive logic, okay, when the theme change, okay, and now React behind the scene must have to keep track of when this dependency change, you're going to run now this specific. Effects events are not reactive and must be omitted from the dependencies. So when you change, now you want to actually trigger that. So React behind the scenes must keep track of when this dependency change for this. Okay. Reading latest props and stay with effects. Okay. Reading latest props and stay with effects. For example, here. To include a number of items to the shopping cart together with every page visit. So you use here but I think this is something quite crucial here as a way to understand that. How now states and effects look at the event handlers. Okay. That'll be all for this video. Take care. Bye bye.